Hello everyone, today we are going to solve this official guide to GMAT Quant Review problem number 208 from the 2020 edition. This problem is also known as DS05302 if you want to look it up. Before we get started, if you have any questions or comments on the approach here, please feel free to put it in the comment box. I personally respond to every comment. If you have an alternate approach that you think is better than the approach defined here, I am always open to new ideas and different ideas. Please feel free to comment your approach. If you like this video and find it helpful, please do not forget to press like and subscribe to my channel. It helps me a lot with the YouTube algorithm. And for more such questions, please join my Facebook group and my WhatsApp group. Details on how to join will be in the description. So let's get started. Okay, so let's first understand what is given to us. There is a tank and it started to leak. It's not given how fast or how slow it is leaking at this point. And the question asks us, did the tank contain more than 30 gallons of water when it started to leak? And we are also given this conversion and we don't know why yet unless we go into the statements. So let's unpack this a little bit. Let's draw out a tank here. Pardon my drawing. Let's assume it is filled with level L and this is the water and it starts with a leak right here. Let's assume all the water that is getting leaked is getting collected in this bucket. Of course, there is no bucket and it's an assumption, but whatever water is going in out here is going somewhere, right? So let's assume it's going in a bucket. So there are two ways to look at it, right? One is the leak has started and the water is collecting here. And one thing that you need to understand is whatever volume of water, so let's say 1 liter of water collected here, that means 1 liter of water leaked from the tank, okay? The other thing that is not given and you cannot assume at this point is how fast it is leaking. So maybe there were just drops of water here and there leaking in, or maybe it was leaking in streams, or maybe a combination. So sometimes it was a drop of water, sometimes it was leaking very heavily, because it's not given, first of all, what is the rate of leak, and it is also not given that the rate of leak is constant. So we cannot make assumptions that it would be constant. And finally, the question asks, did the tank contain more than 30 gallons of water when it started to leak? So let's mark this level as 30. When it started to leak, did it have more than 30? So anywhere above 30 is a yes to ask question. Did the tank contain more than 30 gallons of water? Yes. Anywhere below this is a no to the asked question. And if we cannot figure out where this level of water was, then it's a maybe and it's insufficient to answer the question. Now let's start taking one statement at a time at this point. So statement 1, the water leaked from the tank at a constant rate of 6.4 ounces per minute. So before we look into this ounces thing, and this is where this conversion would come into effect. However, let's understand what it's saying. Remember, we said that we don't know if the rate is constant, which means sometimes it may have dripped, sometimes it may have gone faster. Now it is given that there is a constant rate. So that assumption is thrown out of the window, and we now know for certain it is a constant rate for statement 1, and that constant rate is 6.4 ounces per minute. The question asks us 30 gallons of water. So I would prefer to keep everything in gallons because my measurement is around gallons. You could do it the other way around and convert 30 gallons of water into ounces. However, I would do the opposite way. So I would try to convert this 6.4 ounces per minute into gallon. I'm also going to do something else. See, ounces is a smaller unit than gallon. So if you just convert ounces per minute into gallons per minute, you're going to get into decimals. However, what I'm going to do is convert it to per hour, because if we convert it into hourly rate, it would be easier to manage. So my strategy is basically I'm going to convert this 6.4 ounces per minute into something gallons. per hour. All right, so let's look at that. So statement number one, first step is converting the 6.4 ounces per minute to gallons. We are given 1 gallon equal to 128 ounces. That means 1 ounce equals 1 by 128 gallons, which means 6.4 ounces equals 6.4 divided by 128 gallons. We are also given per minute. So if I have per minute, so 1 minute equals 1 by 60 hour. So when I divide by 1 by 60, the 60 goes up and 1 comes down. So this is per hour. So gallons per hour. Let's make the conversion here. I am going to take out this decimal point, add a 0 here, cross them out. 64 is just half of 128, so that is an easy calculation. And then 3, so this gives me 3 gallons per hour fairly quickly in mere seconds. Now let's unpack this. I'm given that the rate of leak is 3 gallons per hour, but I'm not given how long it leaks. Remember, it is going down at 3 gallons an hour, but I don't know how long it leaked. So let's assume that 5 hours is how long it leaked and it got completely empty. So then the starting point was somewhere around 15 gallons. If it leaked for 10 hours, then initial start point was 30 gallon, and anything more than 10 hours, the starting point was more than 30 gallon. The thing is, we don't know how long it has leaked for and what is the remaining volume. So other possibilities, let's say it has leaked for 5 hours, which means about 15 gallons has collected here, but this is not emptied. It has not emptied yet. It is still leaking, in which case there would be some volume of water here. So total initial volume would be 15 gallons plus this V. Right? So basically we don't know anything, and hence 1 is definitely insufficient by itself. Let's take statement 2 at this point. Forget about what was given in 1 where a constant rate was given. Now at 2 we are back to square and back to square 2 maybe. In 2 we are back to the initial information given to us where we don't know what the rate is. So now the tank is given to be emptying in less than 12 hours after it started to leak. So let's assume the rate was still constant of 1 gallon per hour since the rate is not given, in which case if it got empty in less than 12 hours, I can say that the maximum volume it had was 12 gallons, right? 12 multiplied by 1. If the rate of leak was 2 gallons per hour, then it will be maximum volume it had was 24 gallons, and so on, right? If the rate was 7 gallons per hour, let's say, then in 12 hours it would have gone 84 gallons, which is more than 30. So again, I cannot sufficiently or easily say what is the right amount of the starting volume. It could be less, it could be more. Hence statement 2 is also insufficient to answer the question. So now let's take 1 and 2 together. In 1 we calculated the rate was constant at 3 gallons per hour, right? Let's reread the question based on this. Did the tank contain more than 30 gallons of water when it started to leak? So if the tank had 30 gallons of water, then it would take it 30 divided by 3 equals 10 hours. So more than 30 gallons means more than 10 hours. So to answer this question, yes, I would have to keep this leak running for more than 10 hours. For to answer this question sufficiently at no, I would have to keep this tap running for less than 10 hours, and it should empty out within that less than 10 hours, and then I would know that it didn't have 30 gallons to start with because it got emptied within the 10 hours. So let's make sure we write that down. It must be empty within this 10 hours. Statement 2 says the tank becomes empty less than 12 hours after it started to leak. So less than 12 hours, where does that lie? Less than 12 hours could mean 10.5 hours. It could mean 11 hours. It could mean 11.5 hours. which all of which lie in this category, right? Which answers the yes to the asked question. And less than 12 could also mean 9 hours, 8 hours, 7 hours, which lie in this category, that the tank is getting empty within less than 10 hours, which answers a no to the asked question, because the initial volume in this case is less than 30. Again, we come to a point where we cannot sufficiently answer a unique yes or no to the asked question, and when that happens, we call it insufficient. So when one and two combined, we still get a insufficient. Hence, the answer to this question is D. Neither of the statements together are sufficient to answer the question. I hope you found this helpful. Again, if you have any comments or questions around this question, please feel free to put in the comment box. I personally respond to each and every comment. Thank you very much. Have a great day.